my favorite equations. It's one of the most useful ones in physics, actually. Ke stands for kinetic energy, the energy an object has because of its motion. Kinetic energy is equal to 1/2 of the object's mass times the square of its velocity. Don't forget, it's the square of its velocity. Now, this equation has lots of great uses. Let's take a look at a couple of examples of how we could apply this equation. First of all, let's look at the units. Sorry about that. We need to take a look at the units. Kinetic energy, which we abbreviate with Ke in the equation, is measured in joules. And it's worth noting that any energy can be converted into kinetic energy. So if I tell you how many joules of gasoline a car has, that can be expressed as kinetic energy once the car is moving. If I tell you how many joules of potential energy an object has, you can figure out how fast it's going from the kinetic energy it has when it converts it. Now, the mass of the object in the equation is going to be abbreviated with the letter m, and we're going to measure mass in kilograms rather than grams when we use this equation. When we're working with joules, we want to use mass in kilograms, and the velocity, which we abbreviate with the letter v in the equation, is always going to be measured in meters per second. Now, a meter per second, just so you know, is basically about 2.2 miles per hour. So it's just a measure of how fast something is moving. Now, let's take a look at some examples. So if the question we had is, how much energy does it take to get an 895 kilogram car to go for 44 meters per second, what we would do is we would use our equation here, and we would substitute in, let's see, we are looking for how much energy, so what we're looking for is kinetic energy. Therefore, what we have to know is the mass and the velocity. Now, half the mass, let's see, our mass is 895 kilograms, so I'm just going to say 895 kilograms. Now, we're going to multiply by, and don't forget it's the square of 44. Now, that should give us the kinetic energy that we have here. So let's just go ahead, take out our calculator, and enter this information. You'll see it's not as hard as you may think. Well, my calculator's over here, so bear with me. Okay. So this squared is best expressed using this button right here. If you look on a TI calculator, it is basically up and over from the 7. You'll see you have x squared. That is a very useful button to use, and I definitely encourage you to use it. And if you notice, the second function that is the square root, which we'll be using later. So let's just enter this information. I'm going to say 44 squared, and notice it shows 44 squared now, times 895 times, and I'm just going to multiply by 0.5. I could divide by 2, but I'm just going to multiply by 0.5. 0.5. And there is my answer. Let's just go ahead and write that down. The kinetic energy is 866,360 joules. However, I notice I have 3 significant figures here. I have 2 significant figures here. This 1/2 is not a measured quantity, so I don't have to let that be part of it. So I need to limit myself to 2 significant figures. I'm going to keep the 8 and the 6. Since this 6 here is more than 5, I'm going to round this up to a 7, and I will get 870,000 joules. Let's take a look at another one. A runner uses 1,575 joules of chemical potential energy in the form of food she ate in order to go 7.5 meters per second. What is the runner's mass? So in this case, instead of solving for Ke, we're solving for m. So we want to know what m is. We simply need to substitute in for Ke and v. So let's just see what we have here. We've got 1775 joules, that's kinetic energy. I'm sorry, 1575. 1575 joules equals half the mass times the velocity, which is 7.5 times 7.5 squared. So what I'm going to do now is I'm going to go ahead and say I don't want m to be divided by 2, which is what 1/2 is. So what I'm going to do is I'm going to multiply both sides by 2 times 2, because 1/2 times 2 equals 1. So now I have is 2 times 1575 joules equals m times 7.5 squared. Well, I don't want to multiply mass by 7.5 squared, so I'm going to divide both sides by 7.5 squared. If I divide both sides by 7.5 squared, then I'm left with simply mass. So what I'm going to do then on my calculator is I'm going to enter using a button you need to know about here. Okay, so what I'm going to do is I'm going to say, let's try doing it so we can see what I'm doing here. I'm going to say 2 times 1575 divided by, now watch what I'm going to do here, I'm going to say 7.5, and I'm going to hit this button here, the square button. That button is your friend. It makes order of operations a non-issue. Now look what I've got here. That's what you want to see. 2 times 1575 divided by 7.5 squared. And when I hit enter, I see that I get 56 kilograms. My answer is 56 kilograms equals the mass of the runner. Let's try another one of these. The brakes of an 888 kilogram car gain 575,000 joules of heat energy as the car comes to a stop. How fast was the car going initially? So what I need to do in this case is I'm going to use this equation, but in this case I'm solving it for velocity, which is going to be tricky since the equation gives me velocity squared. But the first thing I need to do is substitute in the amount of energy that the brakes gained, which in this case they gained 575,000 joules. 575,000 joules equals 1/2 the mass. The mass was 888 times v squared. Now what I need is I got to get v by itself. That's the way I do things. So I'm going to first say, you know what, half of 888 is 4. Well, you know what? No, I'm not even going to do it that way. I'm just going to say I'm multiplying this by 888. The opposite of multiplying by 888 is dividing both sides by 888. If I divide both sides by 888, the 888 goes away from this side. Now what that leaves me with is 1/2 times v squared equals this. I don't want 1/2 times v squared, so the opposite of multiplying by 1/2 is multiplying by 2. So I'm going to multiply both sides by 2. And 1/2 times 2 is 1, and 1 times v squared is simply v squared. Now look what I've got here. Be real careful here. This is a common problem for my students. This is going to solve for v squared. What is the opposite of squaring v? It is taking the square root of it. What I need to do is to take the square root of both sides. If I take the square root of both sides, what I'm going to get is just v, because the square root of v squared is v. So what I need to do is take the square root of this. So what we'll do, take your calculator. Second function of x squared is the square root. See it there? Look what it gives me. It says there, I'm going to take the square root of whatever you tell me. So here's what I'm going to tell it. 2 times 575,000 divided by 888 divided by 888. Now I'm going to close the parentheses. So what I'm going to do is I'm going to say parentheses, enter, and there's my answer. The velocity is 35.986. V equals 35.986. I need to round my answer to 3 significant figures. So in this case, this is 8 is going to round this to a 0, so it's going to be 36.0 meters per second equals the velocity.